Okay, welcome to NYC Python Lightning Talks. Our first speaker is Brian. Brian, why don't you take it away?
Okay. All right, 1 second. Good evening, everyone. I'm very glad to be able to share this project with you. Can everyone see my screen?
I can.
Awesome. Okay, well, how can we read someone's personality? Currently, we have the Myers-Briggs quiz, which uses 93 questions to do 4 binary classifications. This results in 16 personalities. But can we do better? Wouldn't it be a lot faster if I can just paste text into a website and it classifies me using NLP? I'll do a brief overview of my dataset, my features, my models, and scores. My dataset consists of labeled posts from the Personality Cafe online forum with over 8,000 people, each with 50 posts. Next is my 4-step pre-processing of the dataset. You can follow along with the pink line in the bottom. I first remove links, then I use spaCy to tokenize, lemmatize, and remove stop words. Third, I use regex to remove numbers and punctuation. Finally, I use TF, IDF to vectorize. After pre-processing, I'm left with a unique array of words associated with each person and their personality type. In order to make sense of these bag of words, I made topic features. Using non-negative matrix factorization, a form of matrix factorization that reduces dimensions using topic modeling. As a result, the words meet and relationship are clustered on the left under dating, and entertainment words were separately clustered, shown on the right. 40 unique topics were thus created, and these unique topic frequencies were then used to predict personality type. You can explore these further in my Tableau public, link on the left. Finally, let's talk about model performance. This project is interesting because my dataset had 4 distinct targets, each with their unique class imbalance. In order to remedy this problem, I oversampled to fix the imbalance and fine-tune a separate model for each attribute. These scores were better when compared to just guessing the majority class, but significantly better when aggregated to an overall score. Predicting your exact Myers-Briggs basically becomes a coin toss. And that just blows the probability of randomly guessing your 4 letters, which would have been 6%. Here is what I'll replace the 93 question test with.
Hey Navish, what is your Myers-Briggs?
Hey Brian, so I'm an INTJ.
I inputted Navish's text into my app, and my app predicts that he is an INTJ.
Awesome, looks like your app is working.
It also outputs a word cloud of his writing, as well as the top 3 topics that he mentions, and then compares it with all the different personality types to predict the ideal one.
This makes it a lot easier for people to get classified, but...
Hey Navish, what is your Myers-Briggs?
Can we do better? I added additional features by implementing parts of speech tagging and sentiment analysis into my model. But that reduced my accuracy. So given more time and domain knowledge, I would like to successfully improve my prediction using these features. Once I learn more about complicated models, I'd like to implement writing pattern recognition. And the nice feature to add to my app would be a document upload option. Thank you very much for checking out my app. You can interact with the app and Tableau visualizations using these links because I've actually deployed them online. My name is Brian Tam. I graduated from UC Berkeley with a degree in engineering, and I worked in the industry for 2.5 years with experience analyzing geospatial data during that time. I recently completed Metis Data Science Bootcamp, and I'm currently completing a master's degree in analytics from Georgia Tech. I am currently job searching for data science positions. So feel free to reach out to me via text using this number here or my email address. Thank you very much. Let me know if you have any questions. I'm open for Q&A.
Great. Thank you so much, Brian. Does anyone have any questions?
Hey, Brian, it's Niels. Thanks for the talk. It was great. Do you think that since you're trying to predict personality, that actually removing stop words and punctuation, or those things actually reveal something about a personality as a maybe a next step for your project?
Yeah, so it was something I considered. For example, maybe an ENFP would like to say the word like a lot more, and the frequency of that word actually has significance. However, generating a word cloud of all these different personality types, I realized that the stop words were abundantly the most prevalent words in all sorts of personality. The word the word the word like, the word love shows up over and over again. And so in order to try to dive deep into why your people of a certain personality speak a certain way, I felt that the best way to do so is to analyze what were the most frequent topics that were prevalent in their posts. So someone who talks mainly about playing games and meeting people and having friends and whatnot is most likely an E versus an I. And so I was able to show that. And then using my Tableau visualization, I actually showed all the different topics that were and how frequently they occurred for each personality type. And ENFJ has a distribution that on average looks like this. And then ENSP looks like that.
Gotcha. That makes sense.
Yeah, this is great. Can you show us the apps that you've built?
Yeah, sure. I already created it using so Spring app. So here's an app, and then I can just type in let's say my speech. And then I click the predict button, and then it predicts my personality type. And then over here, it provides a link to the personality type that I predicted, and you can click on it to show more about that information. And then also on here is a word cloud of the words that appeared the most in this text, and then some sort of a prediction of the topics that showed up the most often. And then a little GIF showing the the Tableau public that I had in the other page.
That's great. I have a question and a comment. So I think for next steps, you asked, are they, is the prediction correct? I wonder if there's a way that you could then capture that information for retraining.
Yeah, for sure. And then input. So every single time someone puts in a prediction onto my app, if it could record that in like a spreadsheet of some sort and then retrain the model, I think that iteration would be kind of interesting to implement. Yeah, thanks for sharing.
Very cool. Any other questions for Brian? In that case, I have one last question. So what inspired you to build this?
So I am a heavy extrovert. I am my Myers-Briggs is ENFP, and so talking to a lot of friends, I really like them talking about the 16 personality types and trying to figure out, psychologically analyzing why a certain friend is a certain personality type and what exactly that means for us. I think that it's a conversation starter to be like, hey, this is my personality type, and based off of that, these are my attributes. And obviously it's not perfect, but it is something that really dives deep into simplifying this complex emotional and personality array of that everyone has. And so I wanted to make the 16 personality type quiz even easier by having people play around with this app, where they only need to copy and paste and click a button. And it's a lot simpler in that sense. Oh, thank you very much. I appreciate that, all the questions.
Great. Thanks so much, Brian. So I'm going to unpin you. And next up is Neda.
Hi, just 1 second.
So as Neda's getting that set up, just wanted to remind everyone that the sign-up sheet for talks is still open. So go ahead and open that up and sign up if you're interested in speaking tonight. Take it away, Neda.
Okay, so hi everyone, I'm Neda, and today I'm going to be talking to you about my data science bootcamp passion project on using computer vision to classify Muay Thai moves. And so before we jump into it, I'd like to briefly mention a bit more about what Muay Thai is. So Muay Thai is a martial art that uses stand-up striking along with various clinching techniques. It's often called the art of 8 limbs, as it's characterized by the combined use of fists, elbows, knees, and shins. And now that we know a little bit more about what Muay Thai is, let's get into the motivation behind my project. So I began training Muay Thai in October of 2019. And sadly, when the pandemic started, I wasn't able to go into the Muay Thai gym I was training at. So training alone at home meant repeating the same combinations that I had learned over and over again, and that any new combos I was trying were either ones that I made up or ones that I saw in fights without getting any feedback on how effective or practical they actually were. So I thought it would be amazing if I could create a model that could watch fights, classify every move, and then record whether the hit landed or missed and if there were any counter hits. And some use cases would be to train another model on that data and have it generate best moves and counters for and against specific fighting styles. And this would also lend itself to personalized training sessions, depending on if a person wants to prepare for a fight or just come up with practical moves and counters to safely practice at home when you can't get to a gym. So to start this process, I downloaded and took screenshots of around 1,150 pictures consisting of kicking, punching, elbowing, kneeing, clinching, and being in the Muay Thai stance. And then I used Label IMG to label the images. And then I leveraged Google Colab's GPU and YOLO v3 with DarkNet framework to train a neural network on the images. And as I mentioned, I had to actually build my own data set for this project since there's no database of pre-labeled moves. At least I didn't find one. So this is what Label IMG looks like. I loaded in all my pictures, and one at a time, I created a React box to draw over the move I wanted to capture. In this example, it's a punch. And then saving it in a YOLO format captures the coordinates of the box and saves them in a TXT file of the same name as the image. I then used transfer learning to train YOLO v3 with DarkNet framework on the roughly 1150 images that I had labeled. And I chose YOLO v3 in particular because it can be used to detect objects real time. And the results were pretty positive. The model is able to classify images, pre-recorded video, and live webcam feed. And let's jump into the results. So I did build an app that it can classify images. It does the best classifying images rather than, or better than video. And I will let it show that it classifies this elbow. And just for the sake of time, after that, I will go into the video classification. So I did build a Streamlit app that lets it classify video, but it runs frame by frame, so it takes a really long time to classify. But just to show you guys, I did run a video through the model, and then, yeah, so just to show you that it does classify video. So it classifies stance, clinch, kicking, and punching the best, and it struggles a bit more with kneeing and elbowing. And the video moves a little fast, so it's easier to tell by the colors on the legend on the right. And you'll mostly see yellow, green, and dark blue, with a few instances of purple and light blue. Okay, and then, so next I'm going to show you the classification via webcam. My brother was kind enough to hold the pads for me to test the model, and now it's not perfect. You'll first see me in the stance, and I'll demo a few punches, elbows, knees, and a kick, and it does a pretty good job for the most part, but unfortunately there are a few misclassifications. It sees the elbows as punches, and it misses a knee, and then towards the end I'm really showing him where to hold the pad, but it misclassifies it as clinching. So I'll throw 2 punches, and then here's an elbow, but it sees it as a punch. And then it does a good job on the knee. And then it also captures the kick. And then next, I'll try it again. I'll do the punches. It sees the elbow as a punch one more time. And then it missed that knee, and then now it sees clinching. And then just for the sake of time, I will skip over the optimizations and feature work, but if you have questions about it, I'm happy to answer. Thank you for listening. I had a really great time working on the project, and I'd love to answer any questions about it, about this or any of my other work, which you could find at my LinkedIn and my GitHub or a few of my data science blogs. So yeah, feel free to reach out and we can have a discussion. Thanks.
This is fantastic, Nida. I had no idea that you were doing Muay Thai. It's it's such a cool project.
Yeah.
Does anyone have any questions? I see in the chat, George says, do you mind briefly going over what you skipped? I think we have time. And I would agree with that.
Okay, sure. Oops. So yeah, so first I skipped over the optimizations I'd like to make. So I want to improve the real-time classification. As you guys saw, especially of elbows and knees, because as you guys saw, it missed the elbow or misclassified it as punches, and then it missed a couple knees. And then also I'd like to improve the optimization or improve the classification from different camera angles, since they're constantly changing during fights. One of the earlier iterations I had implemented, I didn't have very many pictures of the fighting or the camera angle where it's like high above the ring. So I had to go back and get more pictures of that. So I'll probably get more pictures from different camera angles. And then, yeah, for the future work, I'd like to build an app that can go into the user webcam and have people classify their own moves. And then I'd love to keep track of the stats, such as like number of hits and if they landed or missed. And then I'd also love to make another model that can give best responses for counterattacks or for different moves and fighting styles. And then I can let this run. Oh, not this one. This one, which was just the app that I built. So yeah. So yeah, I looked at it's all the elbows, and then next, I think I grab clinching, like a picture of clinching. So I'm like searching through the pictures on my laptop, and then it says that it's clinching, and then next I'll drag in a picture of a kick. And then I'll hit identify, and it tells me it's a kick.
Any additional questions?
Hey, Nada,
Oh, go ahead.
yeah, because we both finished medis in the same cohort, and I just want to say that like, you know, your presentation was spectacular. It was I could tell like you put a lot of time and also like, you know, have it well rehearsed. And I'm just curious, like, you know, because I know that you are working on separate projects post bootcamp, and like can you talk a little bit more about that if possible, just like a sneak preview for next time?
Yeah, I actually was thinking about presenting a different project, but I kind of want to like really make it, I want to improve it and do a lot more before I present it. But but first, thank you for your kind comments. I'm also trying to build a birth control recommender based on reviews of different types. So I have about 60,000 reviews of 113 different birth control pills, IUD, patch, and ring, and one emergency contraception. And I started doing topic modeling on it to get a bunch of different groups and see what people complain about for different drugs. So some people complain about that it gave them a lot of acne or anxiety, depression, things like that. So I'd like to use that and build a recommender that people can put like, oh, I prefer hormonal, or I wouldn't mind hormonal, and they can say, oh, I've struggled with acne and mood swings. And so based on their input, the recommender will suggest to them a specific type that hopefully would work for them. So yeah, that's the project I'm working on now after medis. Yeah, thanks. Hopefully I'll present that one next time.
Yeah, it's a bit short of the time span for this one.
Yeah, generally we let everyone go at least once first, and then we can circle back around. But this is fantastic. Any last questions for Neda? Okay.
All right, thank you.
If not, Niels, you're up next. Let me just unpin
Cool.
here. Okay. All right, you are pinned, and as soon as you get your screen shared, you're ready to go.
All right. Is it up?
Looks
can
great.
people see that? Cool.
I can see developers.google.com.
Yes. Okay. Hi, everyone. My name is Niels. Trying to follow Thomas and present at every lightning talk now. Maybe a 2021 goal. Okay, but that aside, I'll be talking about GANs, generative adversarial networks. You might have heard of this. I think the original paper came out maybe 2016, 15, 16, or maybe earlier. But since then, a lot of new variants and different approaches have come out of the pipeline, the research pipeline. So today I just wanted to give a dust off an old project and kind of demo it and show you how it works. So the main motivation for this was to just get some intuition about how GANs work and how you would implement them and train them. And maybe some of the problems with training them that's not as straightforward as training supervised learning model, because it's hard to know when you're really done or when a generator is doing well. But before that, let me just take a step back and define some things. So the whole task of a GAN is to train a model that generates data such that it follows some kind of realistic data distribution. So in this little Google blog post, we have some real data, which in this case is kind of like this counterfeit type of situation where there's a counterfeiter that's trying to generate money, trying to counterfeit money. And there's a discriminator, say like the police or a bank or something, that's trying to distinguish between counterfeits and real data. And so this is a kind of mini-max game where the generator is trying to fool the discriminator that what it's generating is real. And the discriminator's task is to tell between real data and fake data. So in the beginning, the generator is really awful. And as training goes on, what we'd want to see is that it maybe generates a face to generate some kind of bill, dollar bill, $100 bill. And eventually, what we'd want to see is the counterfeiter is so good that the bank can't tell between counterfeits and real bills. And so conceptually, this is what's happening where you have a generator model that's generating samples and the real world that's kind of generating samples. If you think of the universe as generating data, and it's generating these samples, that this discriminator's task is now to try to tell between, did the sample come from the real world or did the sample come from the generator? And there are losses associated with both. So the discriminator loss will be high if it can't tell if the generator is fooling the discriminator that its samples are real. And the generator's loss will be high if it can't. It's basically the opposite. So their losses are sort of inverse of each other. So with that background out of the way, the simplest kind of hello world case for this is if the data distribution is Gaussian. So say you have a Gaussian distribution and you're sampling from it, and that's your quote unquote real world. And your generator at first is this neural net using PyTorch here. So it's basically a neural net that takes in, where'd that go? Yeah, so this neural net is taking in some kind of noise input. I can, I guess, talk about that if there are any questions about that, but basically it's taking in noise and it's trying to transform that noise through the representations it's learning into something that looks like the real data. So here it's a very simple network that just passes the input through the hidden layers and then outputs this linear output, so this can be any value, negative or positive. So that's the first module. The second one is the discriminator, which is basically a very simple architecture as well. Since we're just modeling Gaussians, it should work pretty well. And you'll notice that in the forward pass, it's outputting this output that passes through a sigmoid function. So you can interpret that as a probability, where the probability, the closer to 1 it is, it's saying that it's real data, and the closer to 0 it is, it's saying that it's fake data. So those are the two modules, and there's some kind of glue and analysis code here, but the training loop looks kind of similar to a supervised network or a supervised training setting, except now there are these two steps where per epoch, you have this discriminator training step where you're generating real samples, you're drawing samples from your real data distribution, and then you're generating data from your generator, and you're computing a loss based on whether it's coming from the real or the fake distribution. So you're training the discriminator here. And then the second step is to train the generator to artificially say that its samples are real. And there's a loss associated with that. And let me just run this script. It's not really ready to share yet, but I'll show you some of the output. So the outputs per 1,000 epochs are related to the real binary cross entropy loss for the discriminator on real and fake data. So you can kind of decompose it and see how it's doing. And then the loss on the generator. And so what you will really want to see is this generator loss going down overall. And to show you, I have a little video here of this simple Gaussian case. Can everyone see this thing? Okay, so I'll just step through this step by step. So on the top, you see the distribution of real fake samples, right? So epoch 0, the fake samples are all kind of these small values because I guess the network initialized to like small values. By epoch 100, you can see the mean, the distribution shift over close to, I think the mean is 4 for the real data. By step 2000, it's close to the mean, but the spread isn't correct. And you can see the metrics here that I'm tracking, the mean, standard deviation, the skew, and the kurtosis. So these are just the stats you would usually look at for testing normality. And then at the very bottom is the losses associated with each of the components of the system across time. So I'll just fast forward a little bit. It kind of shifts over to the right way too much. And then eventually it starts spreading out, but it looks very left skewed. So that doesn't look right. And then by step 20,000, it's kind of looking right, but this right tail is still, I would say, not enough masses going over to this right tail. So I've trained this one for like 1 million steps, and it gets closer and closer to the real distribution, but it like fluctuates, right? Because of this game where the generator is trying to fool the discriminator. And generally you want, they're like, so I'll show you the last thing I'll show. Thing, just a very simple adjustment. So here I'm training a Gaussian mixture. So I have my real data is drawing from 2 Gaussians, sufficient statistics, and it just fails. So the real data is over here at 0, and it just kind of tries this thing here, and this is after 20,000 epochs, and it's not doing very well. So even in this case, I'm not even training images or the crazy demos that you see, but yeah, there are various things that one can try to maybe have the generator copy the real distribution a little bit better. But yeah, I'll maybe put this up in a repo somewhere for people to play around with. The next thing to try would be to increase the capacity of the generator, so it's a higher capacity model, and that can model richer distributions. And with that, thanks for listening.
Great, thank you so much. Does anyone have any questions?
Hi, I actually joined in late, but I had a quick question. I know this problem is the mode collapse problem in GANs. You have a bimodal thing and it kind of collapses.
Yeah.
Is it because you said the generator or the discriminator network is not rich enough, or is it because this is a very common problem, and I think it's got to do more with like, it thinks that there are only samples to the left or the right. Basically, it thinks that it's a unimodal and, it kind of collapses. So I guess there are different ways to solve it, but maybe the network being richer doesn't solve it. What do you mean, like you made the network richer? I didn't get that.
Oh, just increasing the capacity. So.
Oh, you want to say make it a more deeper
Yeah.
network?
Yeah.
Oh,
I mean, again, I'm not an expert in GANs. I was really just dabbling. So
okay.
yeah, I don't know if you have thoughts on how people have actually solved the mode collapse problem.
Okay. But it's kind of trying to model distributions. Yeah. Okay, got it.
Yeah.
Do you have this code on the GitHub or something?
Yeah, I have. Well, yeah. So this was like 2 years ago, so I kind of spruced it up a little bit, but I haven't checked it in. So let me just share that real quick. You can see I'm still using variables, which ages the PyTorch version, the capital variable. Yeah, so this is the repo that I just have my random whimsical machine learning projects. Oh, where's my chat window? Okay, there. Yeah.
Okay. Thank you.
So the GAN Gaussian project will contain all of the code, and you can just play around with it.
Okay.
I think it's fairly good starter code, and you can replace the real data distribution with fancier things, and also the modules, the PyTorch modules.
Okay, got it.
Okay, great. Thanks so much, Niels. Up
thank
next
you.
is going to be Calvin. Calvin, are you there?
Yeah, okay. How do I share my screen? Let's see. Okay, does everyone see my incredibly empty Jupyter Lab notebook?
I do see an empty Jupyter Lab notebook.
That's great. Okay, so yeah, hey, I'm Calvin. I'm a machine learning engineer here in the city. Yesterday, Thomas told me to give a talk, and I cannot deny this man, so I must obey. So if things go wrong, blame him, don't blame me. So anyway, I'm going to talk about dumb effects. So first, I need to tell you what an effect is. I'm also going to, this disclaimer, this is my first talk ever in Python. It's also my first time live coding, so good luck. So what's an effect? So let's suppose I had a function, and because I'm a good Python programmer, I type hemp as much as I possibly can. So a simple function taking an int, say a number, into another integer. Here's a function that squares the function. Okay, so nothing magical is going in here. But suppose I want to print out some other information. So I add in a print statement in the middle here. So you can put the number, let's say num, right? And now when you run this function, oh god, you get extra text that comes with it. However, this extra text is kind of extraneous to the function, right? If you think about it, the function really just is supposed to be like a pure thing. You take a number and you plug it into the function, and I don't care what goes on inside of it as long as it spits out a number at the end of it. But the print statement is very special. The print statement creates an extra thing. It puts output on my screen, right? That's not what the function is supposed to do. I told you the function is an integer, a function from int to int, and it gave me an extra thing. This extra thing is often called a side effect. Okay, and side effects are, they're sometimes bad, right? Because they screw around with what you think the semantics of your program is supposed to do. If you're a good Python programmer, you should be very explicit about what your function is doing. But now you're printing stuff. Like, who asked for that? This doesn't seem like a bad idea because it prints. Prints are, not terrible. Well, what if you wrote, instead of print, you wrote, launch nukes, you know, and that's some function that you wrote that it's an RPC call to some server in Russia that launches nukes. Now that's an issue because you don't know. You thought you're calling a function that squares numbers, right? You import math, you type square root of, you know, or square function, and you're like, yeah, that's it. But instead, it's launching nukes in Russia. Like, what's going on? That's the problem with side effects. Side effects are not captured by the type system in your function in your language, and you cannot reason very well about the things that happen in there. Okay, so this is what it is. What's a special type of effect that you get in order time? Well, a special effect that always happens is called an error. So suppose you had an error, and you know, the rest of the function stays the same. All right, but now, you know, what happens to your function? You know, you run it, and it's an error. That is a side effect, right? If you think about it, that's an effect, because you think that your function is supposed to give you int and send you an int, but instead it spits out an error. No one likes errors, and no one expected this error. That's an issue. Okay, so that, you know, so now I told you what an effect is. Effects are things, extraneous things that your function does that are beyond the type system, and two, things that are kind of not computationally bound, right? You have a mental model of what a computer does, and printing to a screen doesn't really fit your notion of what a computer does, right? Like the canonical computer is a Turing machine with, you know, infinite tape and infinite heads, and now you have screens and keyboards. Like, that's not what a computer is anymore. No one knows that. Okay, so that's okay. So what is a smart thing that Python did? Python gave you one way out of this mess for only exceptions. What is that thing called? It's called a try except handler. Let's see how crazy this thing is. You know, if you call F13 twice, if you wrap it in an exception handler, nothing happens because no exception was called. But as soon as something in here calls an exception, you can catch it. And it doesn't throw an error. You catch the error and then you do something with it. If you think about how crazy this is, you have to appreciate how amazingly crazy this is from a computer science standpoint. You took something that's supposed to just ruin your program and you somehow captured the effect. It's not a return statement of your function. It's just something that happens in the function. Something gets emitted, and then you capture the emission of that thing, you hold on to it, and you do something to it. That's an effect, and that's an effect handler. You have handled the effect. So I'm going to type the word effect handler, because this is basically what my talk is about. Effect handlers. Okay, effect handlers are cool. It doesn't, but notice that the F error is the first thing called inside a nested group of functions. So in your stack trace of functions, if you knew what a stack trace was, it's deep in there, and somehow you still capture it deep within. Errors get propagated from any function deep inside, get pushed out, and then gets captured by the handler and then done something with that. In JavaScript, you would have to go through multiple levels of what they call callback hell just to do this. But in Python, you just capture it like this. Now you're like, okay, great, I can do exceptions. Who the heck cares? That's like one thing. But it turns out that lots of things in Python are effect handlers. For example, context managers are actually exception handlers in disguise. So, you know, if I wrote an exception handler, like, you know, my context, you know, how do you define exception handler? You have to add in context. And suppose what happens when you enter this exception handler, you print out entering. And when you exit, you exit, right? So that's a handler. And now, if you think about, you know, what does this do? You know, when you run this piece of code, you know, first you do the enter, you run your function, and then you exit. Okay, that's not remarkable because you can write that. It's super stupid. So what's the point? The very special thing about context handlers in Python, especially Python 3 point whatever and higher, I don't really know, but the special thing is what happens when an error happens in there. Does anyone want to guess what happens in an error? Come on, let's guess. What happens when an error happens? I put an error in here, so what's going to print? It's going to print entering, nothing happens in the error, and then what?
Does the error output or?
It does output, but what is there anything else that prints? Just by the ordering of what this is. So F error, remember, raise the exception in the very beginning. So you should technically never hit the statement, right? You'll never hit the print statement. So how many lines are get printed? So think about what your mental model is supposed to be. You enter the exception handler, or you enter the context handler. So entering gets printed. You hit the exception, the error happens, right? You should just bump out. You should just throw yourself out of the program immediately. Like it's over, game's over for you. But yet somehow the last statement, the exiting statement, still gets called. Like context handlers actually somehow secretly took the exception, ran through its exit statement, and then threw back out the exception for you. Like it just ran it again. It actually does something under the hood. Context handlers are exception handlers. They took and actually handled it by waiting on it and then waited till you exited and then threw it back out to you. You can redo this entire exception handler by just writing a try except block. You can write this try except block this entire thing. Sorry, I should be an error. This does the exact same thing as the above. What I just showed to you is that your with statement can be rewritten completely as a try except block, meaning in Python, these two constructs are equivalent. There is no difference between these two, okay? All right, so I've just waxed a lot about the try except block and the with statement. The reality is, who cares? Like, what's other than exceptions, what can you do? In the beginning, that's probably effects. Effects were things that your program did. It emitted these magical actions, and they could do anything. Printing, if you think about it, takes this thing and does something with it, okay? It emits a statement and prints it out to your screen. But if you think about it, what if you could handle the print statement? What if, suppose you wanted to take every statement that you printed, and instead of actually printing it in screen, it would first put it in brackets and then print it out. So could you write something that when you wrote print, instead of every time you printed, it would take the thing, automatically wrap it in brackets for you, and then printed that out? Let's try that with an effect handler. So what you're supposed to do, if you think about it, is you take the thing and you wrap it in an exception, and then the exception gets pulled, it gets handled by the try except handler, and then you take that value out the exception and then run it. So let's try doing that. So let's write this function called bracket print, and it's super stupid because it returns a string. It doesn't actually return anything because what it's actually going to do is just all it's going to do is going to emit an effect, and the emission, so emit an effect, and the emission is given by the raise statement. So I'm going to wrap my string in a value error, and then I'm going to run this function. Suppose my program was called, I had x equals 5, I bracket print, I'm bad at typing, so please can be like, oh no, what did I do? Okay, so that's the try block, and it's gonna fail, but now I'm going to capture any effect that's being emitted, and I'm going to now, I understand that I'm going to say something about the cheating of using print for a print, but Okay, but now every single time the print's gonna be emitted, it's gonna be captured. That string is then gonna be turned into brackets, and it's gonna be giving me brackets. So instead of making the string, it takes the string in the handler and spits out the words in brackets. Okay. Now you may object, but Calvin, you wrote print. Isn't the point to not write print? No, the point is that I deferred print. In the end, you have no idea how an effect is going to work. An effect works with your hardware, and your computational model in Python knows nothing about your hardware. Print's a statement about your screen, about your terminal, about your operating system, about the chips on your computer. That's implementation detail, but it's not actually part of the computational model of a program. Your program should decouple the idea of an effect and the implementation of the effect. And that's what this program does. The program here is decoupled from its implementation, which is the important thing. This is pure hardware. This is pure software. And that's the entire point of this thing. Now, one problem is that I wrote 2 bracket prints and only 1 got emitted. And that's because exception handlers, once they capture something, you can't go back in. They do not allow you to go back in. So we need a way to go around it. That's the last, if I have 2 minutes, that's the last thing that's going to happen. What you do is, let's just take this entire thing and let's modify it. So now what I'm going to do is, how do I go back? I need one more thing. I need global state, and I need to be able to replay. If you think about it, once I exit out of the exception handler, I have to replay that entire thing. So now let's do that. And this is pretty easy. So how do we get to the second statement? You need global state plus a replay. And so you need a clock. You need a local clock. And now let's call this function the replayability one. So what I'm going to do is I'm going to take my Google clock as a local, and every single time I run this function, I'm going to tick down the local clock each time. And I'm going to keep that local clock as data that I want to keep. So this is my replay function. And now, how do I replay this entire block? Well, I'm going to wrap this entire block in a function, because I can do that. That's my right as a human being to wrap this. This is going to give me an error. I don't know why. Okay. Okay, so I take these 2 globals, and now I'm going to run this over forever with a break statement somewhere. So every single time I run this, I run the clock, I run the try statement now, and at the very end of it, I'm going to wrap it in a break. This should theoretically work. Great. So now it runs through every single one, right? And I can take the statement, and actually this doesn't just work for one. It works for, it doesn't matter. It doesn't matter. We'll just keep running through. Okay. So one minute of pontification. Why did I do this? Why would you ever write programs like this? And that's because it turns out that if I just have exceptions and global state, I get all algebraic effects. There are a lot of algebraic effects out there. Here are ones you might have heard of: non-determinism, stochastic random effects, I don't know, printing. Here's a basic algebra effect. Exceptions, things like that. But other things like autodiff, automatic differentiation, program transforms, vectorizations. These are all variations of algebraic effects. And so in Python, there is an entire vast of libraries that I use this. So under the hood, in some sense, JAX does this. PyTorch does this. Pyro does this. A lot of even though they don't explicitly say it, Pyro explicitly says this. But other than that, in the end, algebraic effects are kind of one way to what's called reify control flow. And if you study programming languages like Haskell, yeah, if you study programming like Haskell, you get this with monads and all that stuff. But in Python, we don't have that. And so study algebraic effects because they will give you cool stuff in the end. All right, thanks.
Great. Thanks so much, Calvin. Will you be available to take questions maybe offline?
Yeah.
Okay, because we have one more speaker tonight and they've opted out from the live stream. So I'm going to go ahead and turn that off now. Let me see if I can figure that out. Actually, any questions for Calvin while I'm figuring that out?
I have a question for Calvin. I'll join in just one second.